Howdy and welcome. I'm Professor Parks, PhD, and today I will be bringing you a talk by a friend of mine, Cal Powell. I met Cal through our involvement with the Northern Virginia Astronomy Club, which I will put their website down below in our description. Cal is a meteorite enthusiast with a rather sizable personal collection of his own, with specimens from all over the world, and representing all different types of meteorites. Meteorites are not all the same. They are not just simply a monolithic type of rock, as Cal will be explaining in this talk. Cal also spends his time with the Smithsonian doing outreach to explain what meteorites are and to use his collection as a representative sample. So if you're interested in meteorites, if you're interested in what they are, what different varieties and flavors they come in, and where they can be found, stay tuned, and I hope you enjoy it. Peace out and clear skies.
So howdy, my name is Dr. Rob Parks, and I am the Deputy Director of the Observatory here at George Mason. And so we seem to be constantly updating the format of this event series. Right now we are doing hybrid. So we have obviously you folks in person, which I'm very, very excited about. And then we have a collection of folks that are online. And so the way this is going to work, hopefully, is we're going to go through the event here in person. And then we're going to go to the observatory once we're done with this portion of the event. Those of you online, you're going to stick around if you'd like. And one of our tour guides is going to, online, give you a closed dome tour of our observatory, kind of let you know what we do here, how things get done, that sort of thing. The rest of you, we're going to actually meander over to our observatory. And if it's clear, which I don't think it is, if it's clear, we're definitely going to open up for you. If it isn't, then we'll give you a closed dome tour and just talk about the observatory, and particularly if it is cloudy, when you can come back, because we are now instituting a new sort of thing here where we have public hours on Thursday, Fridays, and Saturdays, where I can't remember the exact times. Basically, we open up the observatory for an hour on those days, first come, first serve. If you want to come, great. If not, and then also we have, if that time is inconvenient, we also will continue to be doing private tours for those who request. So without further ado, let me get my screen. All right, hopefully you all can see that at home. Again, if you can't hear me, please let me know and I'll try to adjust that. As I said, welcome to George Mason Observatory. This is a talk series that we do, Evening Under the Stars. So, that work? That work? Every time, I just can't check. No. Okay. So, yeah, so we are Evening Under the Stars, like I said. We are the telescope. If you are familiar with campus, the telescope is on Research Hall or attached to Research Hall, which is that away. Our nice silver dome. Our telescope is on top of it. That right there is our control room. That's essentially where we're going to be taking you after the portion here is over. These images that you see along the outside, those are images that have been taken over the years by students here at George Mason. These are sort of the first generation of images that have been taken. We are constantly growing an active students organization, club, and also undergraduate and graduate research. And they're constantly not only doing work with the telescope, but also having fun in creating pretty pictures like this. When I say that this is the first generation, this is what we're doing now, or trying to do now, is there is an iconic image of Hubble, which is called the Hubble Deep Field. And not to go too much into it, but essentially the director of the Hubble telescope said, I need this many hours or this many orbits, and I want to look at absolutely nothing in the sky and see what I can see. And he created one of the most iconic, scientifically important images in science because what he found was just an amazing field of galaxies that no one had ever seen before. So we're kind of trying to do that here in a way. What we're trying to do is we're trying to expose our known object for as long as we can, get as much light as we can. For instance, this is the Cocoon Nebula. From my understanding, they collected 17 hours worth of data to create that image. This is something that is currently ongoing. This is a spiral galaxy whose name escapes me at the moment. That is, like I said, currently being in progress. But that's the sort of thing that we're trying to do here. Evening of the Stars, as I said, is a speaker series plus observatory tour that occurs Thursday evenings from 7 to 9. It is hybrid. You can join us here in person or online. We try to get them every alternating Tuesdays, but really it's twice a month at this point. So the next one is going to be the 21st of this month. The format is a 30 to 45-minute talk, followed by about a 10, 15-minute Q&A. And then we have the telescope tour itself. The observatory is not a one-person operation. As I said, my name is Rob Parks. I'm the deputy director. Dr. Peter Plavchen is our director. And then we have a number of graduate students and tour guides. Em is one of our graduate students who's going to be helping us out. And Nasir, right there, is one of our tour guides who's also going to be helping us out this evening. In addition to that, particularly if you're a student of the university, I encourage you to go to investigate the Friends of the Observatory. I don't know if this still works, but this is supposedly a code to get you to Discord. Jonathan Saldana is the current president. He does. Oh, sweet. File changes. Jonathan is doing great work with the club, and he has greatly managed to expand it. They are currently meeting once a month, just for a meeting, and then they get the run of the telescope every other Tuesday. So Photon, the Friends of the Observatory, is going to have a photo night, where next Tuesday they get to have the telescope for about 3 hours, and under supervision, they get to pretty much do anything with it they want. And then, they are also learning about astrophotography, as I said, and they're going to be taking trips to other observatories along the eastern seaboard, like Green Bank in West Virginia, which is a radio telescope. If you're interested in what we do here at the observatory, just in a more casual sort of sense, I encourage you to subscribe to our newsletter, The Moon, where we feature stories about our students, what our research is doing, and just basically topical, what's happening in the sky, that sort of thing. If you like what you see and you would like to help us grow our department, because one of the things that I personally am trying to do here is I am taking the reins of our public outreach, and I'm trying to bring our astronomy not just here to the campus, but also to schools around Fairfax, elementary schools, high schools, that sort of thing. We have telescopes and an inflatable planetarium that we are very much wanting to actually bring to folks who would request them. But unfortunately, that does take a little bit of financial support. So if you like what we do and you'd like to support us in some way, please consider becoming a patron of the observatory. Now, without further ado, I'd like to introduce Mr. Cal Powell. He is a friend of mine from NOVAC, the Northern Virginia Astronomy Collector. He is a club collector. He is a meteorite collector. His collection now is over 400 specimens, as he says. About that. And he is a part-time planetarium lecturer at planetariums, or has been a part-time planetarium lecturer at planetariums in Connecticut, and has presented the stars tonight at the Einstein Planetarium at the National Air and Space Museum, among many, many other things in his career. So I will switch it over to his slides, and he will talk about postcards from space, postcards from the solar system, postcards from the solar system, and then after that, we will brighten the lights, and you are all free to come up here and explore his collection as well. So without further ado,
That's me with my telescope and my game face on. Good. Okay. Thank you. Welcome. Cal Powell. Thank you very much. And thank you, Professor Parks, for inviting me. And good evening, Patriot Nation. You guys. Okay. So what I'd like to do is run through some visuals for a while and talk a bit and get through as much as I can, and then have you spend some quality time with some of these specimens here, which the ones that are out, you are free to touch, pick up. Please be gentle, and you can also take photographs of them or with them as you see fit. So I'll start off. 10 years ago, next week, as a matter of fact, at about 9:20 in the morning, a very bright light showed up in the sky over the southwestern part of Russia. And people went running to their windows because this thing for a brief period of time outshone the sun. So unfortunately, about a minute or two later, the sonic boom hit, and the concussive shock shattered windows of about 7,200 buildings in the area. And about 1,500 people were injured from things like flying glass. So a little bit later on, they found many rocks, including this large one, which punched a hole in a pond out there. And so it could only leave us with one conclusion. Chicken Little was right. But anyway, I do have a specimen of Chelyabinsk, which is what the meteorite is called, here on the table. So my journey started with a gift, and that's also here on the table, by the way, of a meteorite. And then didn't think, more than a normal appreciation for a gift. But a few years later, it hit me. This would be good for a cloudy day astronomy outreach. And so that's when I started really seriously considering collecting. I'd like to talk about a few basics in terms of meteorites. There's a thing called a meteoroid, which is a small solid solar system body just hanging out in space. A meteor is a meteoroid that enters Earth's atmosphere and will glow due to frictional heating. Your proverbial shooting stars or falling stars. Those usually aren't much bigger than the eraser on a pencil. And a meteorite is a meteoroid or a piece of a meteoroid that survives its trip through the atmosphere and can be found somewhere here on Earth. And so I've got a nice little animated GIF file that shows the difference between those three concepts. So if you see something fall and pieces are recovered, it's called a fall. That's a very technical term. As opposed to a find, which is a meteorite that has not been witnessed or documented falling through the atmosphere. So again, up top here we have Chelyabinsk, and here we have the world's largest meteorite, which is still mostly buried, called Hoba, which is out in Namibia. And as you can see from these lovely pie charts, that it is actually pretty rare to actually see a fall or to recover a fallen meteorite. Most of them are finds well after the fact that they fell. So most meteorites are named for the geographical entity where they are found, such as Chelyabinsk over here. And then they have special rules if multiple meteorites that are unrelated are found in the same location here. And sometimes for Antarctic or some Sahara meteorites, the number after the location contains the year of discovery. A little bit of history. Meteoritic iron beams found in Egypt have been dated to about 3300 BC. And from the tomb of King Tut, they've recovered a dagger, which is made out of meteoritic iron. It's thought to have been a gift to, I think, Tutankhamun's father from present-day Turkey. And the Inuit have used hammered pieces of the Cape York meteorite for lance heads from as much as almost 1,000 years ago. And so I do have a piece of Cape York here on the table as well. The earliest witnessed fall in the Western world with preserved pieces was on November 7, 1492, near a town called Ensisheim in Alsace, that's in France. I got a small piece of that as well. And in 1794, Ernst Chladni published a scientific treatise proposing an extraterrestrial origin for meteorites. Before that time, people thought they must have come somewhere from the Earth. In 1802, though, chemist Edward Howard discovered that iron meteorites contained alloys that aren't found in Earth deposits, and that stony meteorites contained the metal nickel, which is very rare for Earth rocks. Now, in 1803, the question was finally settled when Jean-Baptiste Biot was sent to analyze a recent meteorite fall in Les Hauts-de-France, and he wrote up a report that convinced the scientific community that meteorites were indeed extraterrestrial. So one of the things that I'd like to specify or stress for you young scientists is that it is not only important to do great science, but it is also very important to communicate well about it. Well, the first recorded fall in the U.S. occurred in Weston, Connecticut on December 14th, 1807. And so I've got a piece of that here too. Now, where do meteorites come from? Well, most of them are pieces of asteroids, and they're older than any Earth rock. And so in some cases, there are asteroids that are sort of made of the primordial materials of the solar system, things that weren't quite big enough to form planets in the asteroid belt. And so they have, some of them are big enough to undergo internal heating. When that happens, things start to melt. And when that happens, the real heavy stuff like the metals go to the core, And the lighter rocky material, your olivines and pyroxenes and all those good minerals that you're aware of go to outside that. And then depending on the size of it, well, different pieces break up and the pieces may end up here on Earth. However, not all meteorites come from asteroids. A few come from the Moon and Mars. Something hits those bodies, blasts material off the surface greater than their escape velocity. And again, after thousands or perhaps millions or so of years, pieces might find their way here to Earth. So, meteorites, how are they classified? Well, there are multiple classification systems. There, you can classify them by their structure and physical appearance. And this is sort of the earlier, simpler classification. So it's an older system, easier to apply. And so you'll see a lot of meteorites referred to by that. However, the newer system tries to go and studies the chemical properties of these guys. And so as a result, it's more complicated, but it aids in grouping them by perhaps the body that they might have come from, or the type of body. And just to make things even more confusing, hybrid classification schemes are common as well. So the simple classification is stony, iron, and stony iron. Okay. So it's not too hard to remember. To talk about the stony ones, or the I guess the prevalence of each type, you can see that stony meteorites are by far the majority of meteorites that have been recovered. And that number today is almost 71,000. And so almost 98% are stony. About 2% are iron, and just a 0.5% or so are stony irons. The stony ones have these things in them called chondrules. And they're these little spherical inclusions, little round grains of stuff that are some of the very first things that solidified in the solar system. So what I like to say is that these things were solid and the Earth itself was liquid. And their composition is mostly olivine and pyroxene, which are a mixture of iron and magnesium silicates. And they're usually encased in some sort of what we call feldspathic material, which are silicates with sodium, potassium, or calcium, aluminum. So the stony meteorites that contain these chondrules are called chondrites. And other meteorites are called achondrites, which is a way of saying not chondrite. And you can see how they're kind of broken up into various types. And another technical term, the most common type is called ordinary. You figured. Then there are carbonaceous chondrites, and some of them do contain carbonates, but most show signs that as they were forming in the presence of liquid water. And then there are some others, enstatites, rumerudeites, and the very rare Chondrites. And I think there are only maybe 2 or 3 of these types that are happening, and I wish I had one. So these things that chondrites can contain are calcium aluminum rich inclusions, and they have been dated to be more than 4.5 billion years old. So Those are believed to be the very, very first solids that formed in the protoplanetary disk around the sun. So they formed before the Earth did. They're usually light-colored and irregular in shape, and some chondrites do contain these, and you can see this one has been split in half to show not only the chondrules with these little round doodads here, but the CAIs that contain. And you can see perhaps a CAI or two in the sample of Allende, which is the carbonaceous chondrite that I brought today. And just to show where we think they are formed in the solar system. So here is a schematic of the solar system out to the planet Mars. And so the Tektites chondrites are the ones that seem to have formed around the orbits of Venus and Earth. Other types formed further out. And so you can see now here is Mars and here is Jupiter. And your asteroid belt is sort of in between there. The ordinary chondrites, which are the most prevalent, formed further than Mars and sort of in the inner fringes of the asteroid belt. The Rumeruti chondrites formed a little bit further out from those, and the furthest out are the carbonaceous chondrites, which formed in the outer part of the asteroid belt. And some recent studies indicate that some of them may even have formed further out, even past the orbit of Jupiter to where present-day Saturn might be. It's about twice as far as Jupiter from the sun. Okay, many meteorites, including the stony ones, do contain metal. And most of the metal is a mixture of iron and nickel. Young kids even know what an iron is these days? So iron and nickel are the most common magnetic elements. And as we mentioned before, asteroid differentiation, the melting of the core of an asteroid or the innards of an asteroid results in most metals accumulating in the core. And metal meteorites was one of the early clues that the Earth itself has a metal core. Now, iron meteorites under very slow cooling conditions, like a few degrees every million years, can form these fancy patterns, these crystal patterns that are known as Widmanstätten patterns, easy for me to say, or Thomson structures. And so they're like snowflakes in a way because there are no two that are alike. The Stony-Iron meteorites come in two flavors, basic. One is called a palisite, and those are iron meteorites with embedded olivine crystals. And it's named after a scientist named Peter Pallas, who was the first to really analyze these things. And they are arguably the most beautiful meteorites. In fact, a lot of them are used for jewelry. The other type are called mesositerites. Those are about half rock and half metal. So the simple classification again is stony, stony irons, and irons. Stony chondrites and achondrites. Stony iron, palisite, and mesositerites. And irons, they are characterized by the type of crystal structure they might have, whether it's a hexahedral crystal structure, an octahedral crystal structure, or no crystal structure. Now, the newer classification does take a different additional look at iron meteorites and uses trace elements, gallium, germanium, and iridium, and their proportions to nickel to try and group them together. And they have a whole number of different groups, 4 groups and 7 subgroups, which have been sort of partitioned out, and then sometimes they're merged together again due to more recent studies. So, and even with all that, there's still about 15% of iron meteorites that are still ungrouped. So they're like none of the above. So the newer one is by the type of sort of asteroid they came from, whether it was undifferentiated, weren't big enough to melt out. And so those are where your chondrites come from. You're differentiated, which melted up. So you have your achondrites, which includes most of your irons and some other stony meteorites that come from asteroids that differentiated. And then there's some that are in between, which are called primitive achondrites. So asteroids that didn't fully melt up. And so they have their own relatively rare types of meteorites that we've noticed. How does a guy who's more of a gatherer than a hunter like me get them? Well, nomadic peoples look for anomalous stones in the desert, because that's where most meteorites that come to the market are from, places where meteorites are show up pretty well. So again, these people then sell these meteorites to middlemen in a marketplace, and there might be more than one level of middlemen. And eventually they get sold to dealer collectors. Now, if they're thought to be a new or uncommon specimen, the owner will send a sample to a lab for analysis and classification. The resulting information will then be submitted to a special committee in the Meteoritical Society for official naming and certification. And then, depending on how much they think it's going to be worth, the owner may slice and dice the specimen for sale. Now, there are some things that are associates of meteorites, that's what I call them anyway, things that are related to meteorites. For example, there are these things called tektites, and sort of that's like melted dirt. So it's the glassy terrestrial debris from meteorite impact. They kind of similarly look like obsidian type things, or like lava that you might see. And so I've got several of those up here. There are these things called impactites, and that's earth rock that's either created or modified by meteoritic impact. And so this is one from Germany, where the pounding that the earth took from the meteorite sort of crunched up the rock in sort of like a natural concrete. And that was actually, they quarried that stuff and used it to build their cathedral there without even knowing that they were in a very large crater. There is natural glass, which is the melt product resulting from an atmospheric meteorite explosion. And so again, that's like fried dirt or sand, as the case may be, where something's exploded in the air and the heat melted the ground. And so this is a sample of pica glass, which is from the Atacama Desert in northern Chile. And I have a sample of that here as well. Then there's impact sediment, which is Earth's sedimentary rock that contains evidence of a meteoritic impact, like the one that kind of did in the dinosaurs 65 million years ago. And so I have a sample of that here as well. And just to show a little diagram of tektites, what happens is that they can have all sorts of different shapes, depending on how big the melted piece that came, blasted off the Earth was, how far up it went into the atmosphere, and whether it was rotating or not. And so again, you'll be able to see a sort of a blobby type, as well as one that is shaped sort of like a dumbbell or a dog bone. So some frequently asked questions. How would someone know that a rock on the ground is a meteorite? Well, it would be very helpful if you knew what the common rocks in your area were. And so you'd have to know what the common stuff is to know what is unusual. Having said that, if it's unusual and it is heavier than you would expect a rock of its size to be, that would be a good sign. If it contains the element nickel in it, that would be a good sign. But to really get a final answer, you'd have to send it to a lab. And there are labs that you can send meteoritic samples to that will, for a feed test, and tell you most often that it's not a meteorite, but it might be. How do we know that a meteorite is from the moon or from Mars? And the moon, a little bit more straightforward in that we have brought back samples of the moon from the Apollo missions back in the late 60s and 70s. And so they actually have samples to compare these meteorites to. Mars is a little bit different. So the Martian meteorites contain small inclusions of glass, rock that melted upon the impact from Mars. And those can encapsulate small bits of the Martian atmosphere at the time. And so those gases entrapped in the meteorites can actually be tested, and they match up pretty well with our measurements of the Martian atmosphere on the rovers that we have on the planet Mars. Do meteorites contain any elements not found on Earth? And the short answer is no, because meteorites, being asteroids or parts of asteroids, and just like Earth, we were all formed from the same primordial stuff that was left over from the formation of the sun and the solar system. So there's no elements that are new. All the elements that we know about are the only ones that we see not only in our solar system, but everywhere in the universe. Look. However, meteorites do contain minerals, some combinations of elements that are either rare or not found here on Earth. So, what happens here on Earth is that we have this thing in our atmosphere called oxygen, and oxygen tends to combine with lots of stuff. So many of the minerals that we have here on Earth contain oxygen in one form or another. However, there are meteorites that contain minerals that have no oxygen in them at all, like trololite, which is a iron sulfide, and it has a simple formula, FeS. So, got some recommended reading. We'll be given a quiz after this, okay? Meteorite, How Stones from Outer Space Made Our World is a good general audience introduction to meteorites. If you really want to dig deep into them, the Field Guide to Meteors and Meteorites, even though it's a little bit dated, is still the best overall book. Learn all the details about meteorites. There is a sort of something in between those two for younger readers called What's So Mysterious About Meteorites. And so I have these two books on the table here as well as the younger reader one. There's an e-magazine, or e-zine, I guess I should say, called Meteorite Times. And so it is put out every other month, every odd numbered month. And so it's a good way to sort of learn what's going on in the meteorite world. From a more from a collector's standpoint than from a pure science standpoint. And finally, on my very rudimentary site, I do have a meteorite page that may have some links that may be of interest to you. So what's so special about them? Well, they happen to be the building blocks of planets. They tell us the age of the solar system, including the Earth. They can contain bits of other stars. Allende and others have been studied, and they contain nanodiamonds. And so these are from the cores of stars that exploded long before the solar system was born. Their impacts changed life on Earth. So for those of you in the back, there's a dinosaur on the left is saying, uh-oh. They give us information about asteroids like Vesta over here, Mars, and the Moon. And you can hold a visitor from outer space in your hand. So that's my talk, and let's take a photo with a meteorite. Thank you very much for your attention.
Before we start with the meteorites, if folks have any questions, we can take them now. Actually, I'm gonna take the first one. Are you planning on ever going to Antarctica?
No, I'm not. Again, I'm a gatherer, not a hunter. And so, let me get to, there's a little bit of a backstory behind the answer. Most of the meteorites that you'll find in the meteorite database, official meteorites, come from Antarctica. And that's because they're easy to see there, and because the ice sheet that covers Antarctica acts like a conveyor belt, moving stuff from the interior of the continent towards the coastline, which is where you have certain mountain ranges. So the ice sheet sort of bumps up against the mountain ranges, and then the wind sublimates the ice, exposing meteorites. And so every year, scientists do go down there on collecting missions every Antarctic summer. It would be tough to do in the Antarctic winter. So, but yeah, so they go on an annual basis and scoop up a bunch of meteorites, and many of them end up passing through the Natural History Museum, where they do a lot of classification and analysis of these meteorites that are found there. By treaty, after the late 70s, like 79 or 80, individuals are not allowed to go and pick up meteorites from Antarctica. The meteorites are solely to be used for scientific and educational purposes. And so I do have in my collection an Antarctic meteorite from before the treaty. But because there are a few of those on the marketplace. But I certainly am not likely to go anywhere to hunt meteorites. One of the things about meteorite hunting, first of all, there was a series of on the Discovery Channel, I think a while back, called Meteorite Names, where these meteorite hunters would talk about their adventures hunting meteorites. mostly in places like Australia or the Sahara area. The issue with any of picking up meteorites anywhere is that the laws vary from country to country as opposed to who owns them and whether or not you can legally take them out of the country. So there's a whole sort of web of various rules regarding that sort of stuff. So people do it, but you have to know what you're doing before going into that.
Any other questions?
Yes.
So we admit we're here because of the green comet. So a very basic thing is what's different between a comet, ice, and where that comes from compared with a meteoroid. Space.
Right. Very good question. Yeah, so comets were characterized as sort of dirty snowballs, if you will. So you take a really dirty slush ball and pack it with some dry ice and then freeze it some more or whatever. And you have the basic building blocks of a comet. And the presence of ices in those things mean that they form pretty far out in our solar system. There are a lot of them, especially those that are very long period comets, like the C2022 E3 ZTF, the green comet, have originated probably from the Oort cloud, which is something that has never been seen, but it is thought to be out there. A whole bunch of dirty snowballs out there in the far reaches of the solar system. Again, the asteroidal things are planetesimals that never really got together to form a planet, normally usually because Jupiter, the big bully that he is, decided that he didn't want any planets that are too close to Jupiter, because the gravitational pull of Jupiter would break these guys up before they form fully. So asteroids are more rocky things, although they do have evidence that, ice was around some of them, but they're not mostly ice. Now, having said that, there are a couple of, we don't know of any comets that have exploded over the Earth recently. The possibility is the one that exploded over Tunguska, which was in Siberia in 1908, may have been a comet. It might not have been. It's just because pieces were never found of it. Up here at the table, I actually have a piece of bark from a tree that was felled by that Tunguska blast back in 1908. The Pika glass, though, has been studied, and they think that however many tens of thousands of years ago, a comet might have exploded over what is now the Atacama Desert to create the Pika glass. Because again, it was an airburst, it generated a lot of heat, but not much in the way of traceable solid pieces to be recovered. Yes.
So when it comes to meteorites, would it be like if there did happen to be a fall of like a pretty large one, like at some point recently, like how dangerous would it be to approach it like after, or like how long would you wait? Because I know like it's gonna be most likely very, very hot because it comes into the atmosphere, and then also things like this, and then also like since it was from space, it might have like additional like radiations like that. So
Well, I wouldn't worry about the radiation, and I wouldn't worry about the heat. Because the radiation would probably have long ago, as old as these things are, the radiation would be minimal at best. You'd probably get more radiation from a banana you buy in the store than you would from a meteorite. Now, also consider that these things have come from the cold of deep space. So they are frozen on the inside. And at best, they don't spend a lot of time in our atmosphere to get heated up. And so when they do, that just gives them a sort of toasting. We call that a fusion crust. So that the crust would be melted, but it's very thin. So the people who have recovered things that have relatively recently fallen have said that at most they are maybe a little bit warm to the touch. The answer. Yes.
Do you have a personal favorite in your collection?
I'll answer that the way a buddy of mine, who probably was the person behind getting me started in it. My favorite one is the next one. It's something I don't already have, you know.
I'm smiling because when Cal showed me his collection the first time I asked, I got the same way.
In the back there. Young scientist, Buffalo Bills fan.
Thanks for the question.
Like the rarest kind of meteorite, where does that form? Like what part of the solar system? Like it began with the K, the rarest kind of meteorite.
Oh yeah, those I think they're also from the asteroid belt. So the Chondrites, yeah, I don't know a whole lot about them because I don't have any. But they're very rare. But there are other ones that are rare for, you know, rarity comes about for different reasons. So some are rare because of the circumstances. You know, for example, there are some that when they fall, they hit something on the earth. I mean, not the ground per se, something man-made. And so those are called hammers. And so in 1991 or 92, one went through the trunk of a car parked in a driveway in Peekskill, New York. And so those are called hammers. And I have a little piece of that one here, as a matter of fact. And I've got a book that shows a photograph of the car. So, so anyway, things can be rare for that reason. They can be rare, really rare as a piece of the one that hit a person, for example. That's rare. And there are just some other rare types that, you know, because they're desirable, they are either not too widely available, and if they are, they're very expensive. Young scientist back there. Yeah.
What is the rarest asteroid?
Rarest asteroid? Well, asteroids are pretty common. There are actually millions of them out there. So the asteroids themselves aren't rare, but it is rare to have a fresh piece of an asteroid. And there are some space missions that have brought back pieces of asteroids, and one that we are hoping will bring back a good bunch of asteroidal pieces. So
Rarest meteorite.
rarest meteorite, there are some one-offs, and so they are trying to think. Yeah, I would say any of these Chondrites are rare. There are, if they discover one, let's say that comes from the planet Venus or Mercury, which is unlikely, Venus especially because of its atmosphere, possibility for Mercury, those might be considered rare. So there's just some studies that there are a certain type of meteorite called an aubrite that has some affinities with some of the rocks on Mercury. So they're not sure if that might indicate an origin. So no. Also, but there are a lot of mysterious things about meteorites, and certainly there's a lot to study there as well, and a lot to figure out as to where they come from and what they mean. And one thing that does happen is that the classifications can change over time. that further studies are done. And somebody said, no, it's not this type, it's this other type. And so then some of us have to sort of swear under our breath and go changing our database and changing our labels and all that sort of stuff. But it happens from time to time. Yes.
So I was interested because you said that most meteorites, like 99%, are these stony type.
Yep.
Is that right?
Yeah, or not, yeah, something goodly enough. Right.
Right. But you said of the ones that are found in the United States, only 80%. And you said 20% were iron or something like that.
Right, and that's because the iron ones are more easily recognized. But remember now, most of them are found in Antarctica, where all of them are easily recognized, including the small stony ones. You know, they're sitting on top of the ice. Where's it going to come from? Whereas if a small stone falls on in somebody's front yard or in the forest or whatever, it's unlikely that it'd be recognized as a meteorite. So the iron ones are particularly recognizable. And so that's why you'd find a discrepancy of that nature. In a way, the finds in Antarctica sort of, you know, out of this nearly 71,000 meteorites, about 45,000 come from Antarctica.
So it's not about what happens to hit sort of what angle of the earth.
You know,
It's just what we have.
it's about recognition after the fact.
All right, yeah, I think we'll, you know, what question?
Have you been in contact with what the viewers and fillers of the meteorites?
Okay, some of them have, well, first of all, if you go to say Meteorite Times magazine, they have their last page has some of their sponsors there. But what you can do is some of them have their own websites, and also there's some that are on eBay. Now, having said that, there is a organization called the International Meteorite Collectors Association, IMCA. And so IMCA membership sort of functions the way the Good Housekeeping Seal does, so that you have some recourse should somebody sell you, who is a member of that, somebody sell you something that's not legit. So if you're going to buy off of, you know, eBay or Etsy or someplace like that, I would look for someone who is an IMCA member, because they will say that they're a member and give their membership number there as well.